Thank you, Mr. Clarence Lorena, for introducing us statistics. Now let's have Ms. Cashel for functions and relations.
One of the most important concepts in mathematics is function. In everyday life, we may hear people say, one of the functions of the Department of Agriculture is to provide policy framework, public investment, and support services needed for domestic and export-oriented businesses enterprises. A function is a relation. A relation is any set of ordered pairs, just like this. A function is a relation in which for every first coordinate, which we call the domain, there is exactly one second coordinate, which we call the range. Or for every element of x, there is exactly a uniquely element of y. But take note, functions are relations, but not all relations are functions. Just like us. One question is, how can we determine which are functions and which are not functions? Easy, by using representation. By means of using representation, we can easily determine which are functions and which are not functions. Examples are set of ordered pairs, mapping, graph, equations, or corresponds expressed in words. As we discussed earlier, one of representation of function is mapping. Mapping is using arrows and pictures to indicate functions. There are three types of pairing or matching in this kind of representation. One, what I call stick to one, which we call in function one-to-one correspondence. Two, one-to-many correspondence, or what I call timer. You have one element of x, but a lot of element of y. 3. What I call x's, or past. It is many to one correspondence. There's a lot of x elements to one y element.
Another representation that I want to talk with you is the graph. By using the graph, we can easily identify what is function by using the vertical line test. The vertical line test is to draw a vertical line inside the graph, and if the points meet in one intersection, then it is function. If the points meet two or more, and it is not function. Now let's have function notations. When we use an equation to represent a function, it is convenient to name the function for reference purposes. We know that equation y equals to 4 minus x squared. Describe y as a function of x. If we give the function the name of f, then we can use the following function notation. We can express y equals 4 minus x squared to f of x equals 4 minus x squared. Note, the expression f of x is already as the value of f at x, or simply f of x. This corresponds to the value of y for a given value of x. Since f of x and y are equal, they can be used interchangeably. Letters other than f, such as g or h or gh, may also be used, or any set of alphabet. The first notation is commonly used. F is the name of the function and f of x is the value of function at x. For example, the function notation f of x equals to 4 minus x squared has a certain advantage over the notation y equals to 4 minus x squared. As far as evaluation is concerned, this is if we use y equals to 4 minus x squared, we would have to write when x minus 2, then y equals to 4 minus 2 squared equals to 0. However, if we use f of x equals to 4 minus x squared, we would only write f of 2 equals to 4 minus 2 squared equals to 0. The name of function is f. The domain value is 2. The value of function is 4 minus 2 squared equals to 0. That's all. Thank you for listening. See you at the next vlog.
Oh, Chessmatics! Hi guys! So, that was the end of Miss Keisha Rowing's vlog, and I hope you learned a lot. So, let's go to the next about word problem to be discussed by Miss Eliza and Novia. Bye-bye!
Guys, for today's vlog, I will going to teach you on how to create an equation by word problems. So first, you must know the designated words that being used and signed. So the first that will pop up on my left side, you must think that it is an addition sign. Second, you must think that it is a subtraction. When you see those also, you must think that it is multiplication. It is important to know those words because it can help you to form an equation properly. Let's try some exercises. Let's go. So 12 more than a number is 12 more than an addition, and a number is always x. So 12 plus x is the answer. So an unknown quantity less than 14. So an unknown quantity x less minus 14. So the answer is x minus 14. So twice a number less 8 is equal to 1 more than 3 times a number. So the answer is 2x minus 8 is equal to 1 plus 3x.
So that's the end of my topic, which is the word problem, and I hope that you learned something from me, and see you in my next videos. Bye-bye.
Hi guys! So this is the end of Eliza's vlog, wherein she discussed about the word problem. And now, let's go to the next vlogger, which known as the last night's stand.
Today we're going to learn about mathematical language. Are you ready? Let's start. Let's start by defining language. So what is language? Language is a group of words or symbols that is used to express an ideas. So when we say language, it is not just a group of words. It must have a meaning. So why? Language is used for communication. We use it to communicate. So there must be a meaning with that group of words for us to be able to understand and to communicate. So, meaning, language is a group of words that is used to express and communicate ideas. Okay, for now, let's add the word mathematical. What is mathematical language? So, mathematical language is a language that is used to express mathematical ideas. It is just a language or a group of words or a symbol, but it is very specific. And also, it must convey a mathematical ideas. Okay? And that's the definition of mathematical language. So now, let's proceed to the characteristic of mathematical language. So we have 3 characteristics of mathematical language. So let's proceed to the characteristic number 1. So the first characteristic of mathematical language is it is non-temporal. So what do we mean by non-temporal? Meaning, it is not indicate time. So in mathematical language, there's no past, there's no present, and there's no future. We just have the word is. When we use it in equation, we can use it is equal to, but we can never use it was equal to. It could always be is, and that's the characteristic number 1. Okay, let's proceed to the characteristic number 2. The second characteristic of mathematical language is devoid of emotional content. Mathematics is very objective. I mean, what do we mean by objective? Unlike other languages, it does not convey any other emotion. So when we say addition, we can use happy. Then when we say subtraction, we can use sad. But in mathematical language, there's no emotion here. I mean, there's no feelings, and that's the characteristic number 2. It is devoid of emotional content. Characteristic number 3. So the third characteristic of mathematical language is it is precise. So what do we mean by precise? Meaning precise, it is very direct to the point. Unlike the other languages, they use metaphorical or figure of speech to enhance language. But in mathematical language, we don't need that. It is very direct to the point only. So okay, that's all the characteristic of mathematical language. Okay, let's have a recap. Number 1, the non-temporal. Number 2, devoid of emotional content. And number 3 is it is precise. Okay, thank you so much guys for watching this video, and I hope you've learned a lot about mathematical language and their characteristics. So see you to our next video, and also please like and share and subscribe and click the notification bell for more videos. God bless and thank you so much. Bye bye.
Thank you, Mr. Ivan Tamayo, for introducing us mathematical language. Now let's have Miss Messi Malyabe for modular arithmetic.
Good day everyone, and now I'm gonna show you how to solve modular arithmetic and modular operation. So let's start to modular arithmetic. So when we say modular arithmetic, it is a system of arithmetic for integers, and it is developed by Carl Friedrich Gauss. So as you can see, I draw a clock at my left side. So if I have a given example of 10 plus 5 is equals to blank. So since the first number is 10, definitely in the clock, the hour hand of the clock is pointing to 10. And since you are using the positive sign, so we are going to count it you're going to count clockwise. So from 10, you're going to count 5 times clockwise. So 1, 2, 3, 4, 5. So 10 plus 5 is 3. Next example. What if I have a given of 10 minus 3 is equals to blank? So, since we are using the 10, so the hour hand of the clock is pointing to 10. And since we are using negative sign, so you are going to count it counterclockwise. So, from 10, you are going to count counterclockwise. So, 1, 2, 3. So, 10 minus 3 is 7. Next is how to find if the given example is congruent or not. So let us first familiarize with the two rules. So the first rule is if A is congruent to B mod n, then B is congruent to A mod n. The second rule is if n divides the quantity of A minus B, where A minus B is a multiple of n. So, if I have a given example of 5 is congruent to 8 mod n mod 3, I have a given example of 5 is congruent to 8 mod 3. So, you are going, so how to find whether the given is congruent? So, definitely they have the same remainder. So, all you have to do is to divide 5 to n, which is 3. So, 5 divide 3. 5 divide 3 is 1. 1 times 3 is 3. 5 minus 3 is 2. So, the remainder is 2. How about the second number, which is 8? So, 8 divide 3. 8 divide 3 is 2. 2 times 3 is 6. 8 minus 6 is 2. So, the remainder is 2. Are they have the same remainder? Yes. So, definitely, in this first rule, says that this given is congruent. So, how about the second rule? If we use the second rule. So, if n, which is 3, divides A, which is the first number, minus the second number, which is 8. So, let us simplify. 3 divides, what is 5 minus 8? Negative 3. So, is 3 can be divided by negative 3? Yes. So, meaning to say 3, negative 3 is a multiple of 3. So, this is congruence. So now, let's proceed to modular operations. So we have 3 operations there, the addition, subtraction, and the multiplication. So now, let's proceed to addition. So if I have a given example of 23 plus 38 mod n, so you are going to add first this given, the 23 plus 38. So what is 23 plus 38? Is 61. So copy the mod 12. And now, you are going to find what is the remainder. So, to get the remainder, you are going to divide 61 by 12. So, what is 61 divided 12? It's 5. 5 times 12 is 60. 61 minus 60 is 1. So, the remainder is 1. For the simplified form, we have the remainder of mod 12 is 1. How about in subtraction? If I have a given example of 33 minus 16 mod 6. So same as addition, since it is addition, so you are going to add, but since it is subtraction, so you are going to deduct 33 to 16. So what is 33 minus 16? Is 17. Then copy the mode 6. Then find what is the remainder. So what is 17 divided 6? 17 divided 6 is 2. 2 times 6 is 12. 17 minus 12 is 5. So the remainder is 5. For the simplified form, we have the remainder of mod 6 is 5. So next is the multiplication. So if I have a given example of 15 times 23 mod 11, so same as addition and subtraction, you are going to find what the remainder. So you are going first to multiply 15 by 23. So what is 15 times 23? It's 345. Copy the mod 11. Then find the remainder. So what is 345 divided 11? So 31. Then 31 times 11 is 341. What is 341 minus 345 minus 341? It's 4. So the remainder is 4. For the simplified form, we have the remainder of mod 11 is 4. So that's it. Thank you for listening and hope you learned a lot.
100, 200, 250, 255, 256, 257. Yay! So guys, that was the end of Messi's vlog, and I hope you learned a lot.
And that's all for today, Chessmatics. I hope you learn, fun, and enjoy to our super califragilisticexpialidocious vlog. So before we end,
Please like, comment, and subscribe. Then hit the notification bell for more updates. So that's all mga Chessmatics. See you for the next vlog.
Everything I would do, you were standing there by my side. You gon' be ready for the last ride. It's been a long day without you, my friend. And I'll tell you